This is video 461, and the goal of this video is to be able to graph tangent and cotangent. So we did this investigation in class, and we started to look at the key features of a tangent graph. And we found this table, and then we went through and graphed it. Now, if we graph the table, we'd only get the graph to the right, the one that's in this section here. But if we work to the left and look at some negative angles, we see that we get this wave. So what we should have noticed from that investigation is that the period was pi. But when we talk about the period, we're going to go from negative pi over 2 to pi over 2. So we're going to take and graph the section between those two asymptotes there. So the asymptotes are at negative pi over 2 and pi over 2. And then we'll copy and paste it to the right, like you see there. There's two waves of tangent in this picture. Now, the period of the parent function again gets transformed, and we're going to talk about how to find the key points and the asymptotes for the tangent function. Again, it's 5 things. It'll be 3 points in the two asymptotes that you'll be graphing. So you'll still be looking for the 5 key things. So let's talk about finding those 5 key things. So we have this function. The standard form is a tangent of bx minus c plus k. The first thing that we're going to do when we graph this is we're going to find the asymptotes. The asymptotes occur when the inside of the function, tangent, is pi over 2 and when it's negative pi over 2. That's when the asymptotes occur, because remember on the unit circle, that's when tangent is undefined, when it's on the y-axis there, pi over 2, negative pi over 2. So we're going to figure out when the inside are those two values, and that's when the asymptotes occur. So we're going to solve the function, the equations, 2x minus 3 pi equals pi over 2 to find one of the asymptotes. So we start by adding 3 pi's to both sides. Since 3 pi's is the same as 6 pi over 2, I'm really going to have 7 pi's over 2. So I simply added 3 pi plus pi over 2. Now I'm going to divide both sides by 2. Dividing by 2 is the same as multiplying by 1/2, and since I'm working with fractions, that's a better option, and I'm going to get 7 pi over 4. So 7 pi over 4 is one of my asymptotes. The other asymptote occurs when we get a value of negative pi over 2. So again, we're going to solve an equation to figure out when the inside is negative pi over 2, adding 3 pi's to both sides. Again, 3 pi's is the same as 6 pi over 2. I'm going to get 5 pi over 2. And then I'm going to times both sides by 1/2 and get 5 pi over 4. So I start to think about, that's the sketch. Those are the two asymptotes. Now, you don't need to draw what I drew with those dotted lines. I'm really just trying to help us figure out step 2 now, so you can help visualize what's happening here. After we find the two asymptotes, the next thing we need to know about a tangent function is that right in the middle of that, there's this midpoint. It's the x value that's literally in the middle of the two asymptotes. And so we find that value. In this case, it's 6 pi over 4, because what's in the middle of 5 pi over 4 and 7 pi over 4? Well, 6 pi's over 4. Now, yes, that simplifies to 3 pi over 2, but let's just keep it in force for a matter of convenience here. So that's my middle value, and normally it's at 0, but just like sine and cosine, there could be a vertical shift. There could be a vertical shift, so I'm going to shift this value from 0, and I'm going to shift the value according to k. So same exact idea with sine and cosine. We shift it up and down according to k, same thing with tangent. So normally it's at 0, but in this case, it's going to be at 3, because the k value is 3. So my point that I'm going to graph is 6 pi over 4, comma 3. My graph is shifted up to 3. Now, the next steps we're going to find are 2 more points to help us draw in the wave. And these 2 points could be stretched, they could be caused by, it could be flipped, and so on. So let's take a look at how to find those 2 points. So what we're going to find is the points. First I'm going to jot down what we have from the previous slide. So we have the 2 asymptotes and then the point right in the middle. That's up at 3. Now we're going to find the point on the graph in the middle of the x values. So first I have to find the middle of the x values. Let's take a look at the first 2 x values that I have, the asymptote 5 pi over 4 and the x value 6 pi over 4, and I'm going to find the middle. One option for finding middles is averaging, adding them and dividing by 2. So adding these 2 up and dividing by 2, or timesing by 1/2, because that's equivalent. Now I'm going to get 11 pi over 8. That's the value that's in the middle of those 2 x values. Another way to find a middle, because I have to find the middle again, another way to find the middle is to, well, let's see, what's in the middle of 6 and 7 pi's over 4? Well, 6.5 pi over 4. Now that's not a proper fraction, but 6.5 is in the middle of 6 and 7, right? So 6.5 pi over 4 is right in the middle, but I cannot have a decimal up there. So I simply times top and bottom by 2, change the look of the fraction without changing the value, and I get the number that's in the middle, 13 pi over 8. So I found the middles in 2 different ways. You choose which way works for you, averaging or using the idea of decimals and then timesing top and bottom by 2. And I chose 2 because I knew timesing a half by 2 would cause it to be a whole. So once I find the 2 x values, I'm going to plug in the x values to find the y values. And I have to know 2 facts about tangent, and you'll see what they are in just a second. So I'm going to plug in 11 pi over 4 into my function. So here's my function. I'm putting in 11 pi over 8, not 11 pi over 4, in for x. Now I've got to do some work here. I'm going to times it by 2, and that'll end up canceling 2 with the 8. We'll make a 4. Minus 3 pi over 3 pi, which is the same as 12 pi over 4. Let's make it common denominators as we work through this problem. Subtracting, I get negative pi over 4. But the tangent of negative pi over 4 is just negative 1. So that's easy because that's why I plugged in that point, because it's going to give me an easy value. I know tangent of negative pi over 4 is negative 1. Look at your unit circle. Make sure you confirm that, but you should have that value memorized. Times that by negative 2 and add 3. So I end up getting 2 plus 3, which is 5. So I found the second part of my coordinate, my x and my y. Now I'm going to do something very identical for 13 pi over 8. I'm going to plug 13 pi over 8 in for x. And I'm going to solve. Again, timesing by 2, I get 13 pi over 4. Subtracting 12 pi over 4, I get pi over 4. And then find the tangent of pi over 4. Looking at my unit circle, tangent to pi over 4 is 1. The slope of that line is 1. So negative 2 plus 1 is 1, because it's negative 2 plus 3. Negative 2 times 1 plus 3, is 1. Now I've got my other y value, so I'm ready to graph my rule. It looks like going by pi over 4 is not a bad idea, but I do want to go every 2 boxes, so I have pi over 8's in between. Pi over 8 is half as big as pi over 4, so really my graph here is going by pi over 8. I'm just marking every other because I can't fit in all the numbers. It's too small of a grid for me to write every single number. Now I'm just going to graph these things. I'm going to graph the asymptotes just like we've done with rational functions. Graph them as a dotted line. I'm going to plot my point in the middle and then my other 2 points and sketch in my curve. This is your graph of tangent. Now, I can sketch in another period by simply going the same distance to find the next asymptote and drawing the same exact wave in. This is the second period. I can graph an infinite number of periods, and in fact sometimes you'll graph one, sometimes you'll graph many, but make sure it's a good idea to always graph 2 periods, just so you can see, people know that it continues to repeat. Now, what about cotangent? What's interesting about cotangent, if we back it up here, cotangent is identical to tangent, except for one step. So that's why we left this column blank. It's the same as tangent, except the asymptotes. The asymptotes will occur when cotangents cause an error, an undefined error. And that's not when cotangent is the value of pi over 2 and negative pi over 2 like tangent was. It's actually when the value is pi and 0. So you're going to find the asymptotes by doing bx minus c equals 0 and bx minus c equals pi. Because that's when cotangent is undefined. Think about your unit circle. When we're on the x-axis, cotangent will be undefined because it's the reciprocal of the slope there, and the slope is 0 there. So the 2 asymptotes are going to be at 0 and pi. Otherwise, steps 2 through 4 are the same. We'll look at one example of cotangent just so you can see how identical it is, and it will work the same exact way except for finding where the asymptotes are. So simply change that first step, everything else is the same. So the next example that we're going to look at is cotangent. So we remember first we find the asymptotes. The two asymptotes are going to occur when the value on the inside is 0 and when the value on the inside is pi. Now solving these two equations, this is a little bit easier than the previous example. Well, x has to be 0 to make that value 0, so one of the asymptotes is 0. Solving the second equation, pi over 2x equals pi, well, the simple answer is x is 2 because half pi times something equals pi, well, x has to be 2. So x is 2 or 0 for my asymptotes. I'm going to go ahead and sketch those in, leaving some space in between, of course, because I know my wave is going to go between there. Now I'm going to find the point in the middle. The point in the middle is at 1. And of course, to find the y value, you could always plug it in. So if you forget things like shifting according to k, you could plug in 1 and figure out what you get. If I plug in 1, cotangent of pi over 2 is actually 0 because it's the x over the y, and on my unit circle you see x is 0 and y is 1. So 1/2 times 0 is 0. That should make sense because there was no k value, so there's no shift up or down. So I'm going to be right on the x-axis there with that point. Now I do things like finding the middle again. What's the middle of 0 and 1? Well, it's 1/2. So the number in the middle is what I plug into my function y equals 1/2 cotangent of pi over 2 times 1/2 because I'm plugging in 1/2 for x. Okay, so now I'm going to solve this. Let's see, multiplying pi over 2 times 1/2 is pi over 4. I look at my unit circle. What's the cotangent of pi over 4? Well, it's the reciprocal of the slope there. The slope of pi over 4 is 1, so the cotangent of that will also be 1. So it's just going to be 1/2 times 1, and I'm going to get 1/2 for the y value. So when I plug in 1/2 for x, I get 1/2 for y. Now I have another point to graph. Now I'm going to do the same thing, but I'm going to find the middle of 1 and 2, because that's my next middle of 1 and 2. The middle of 1 and 2 is 1/2, or 3/2, for the sake of working with fractions here in a moment. Plugging that into my function to find y, I'm going to get the value of 3 pi over 4 inside the cotangent, and that is a slope of -1, and so therefore the cotangent is also -1 of 3 pi over 4. So 1/2 times -1 is -1/2. So I have my second point. And that should make sense that it's negative because it's got to be this little wave thing, and then I can sketch it in. Now I could sketch a quick second period by simply sketching in another asymptote at 4 and sketching in another point here, here, and here. Same exact wave. It's all about middles and labeling your key points. And there's my second period of cotangent. So now your job for your checkpoints are, number 1, the multiple choice question is to find the two asymptotes for the function listed here. So practice that first step. The second question is simply asking, what is the I'm going to change the question because I don't know if we're ready to write a possible rule. That's pretty hard for tangent at the beginning. So I want you to simply tell me what happened to the original tangent function. So look at your parent function, you have it on your investigation sheet, and then think about what happened. Did the graph flip? Did it shift left or right or up or down? Think about what happened to the graph. The y-axis, by the way, is scaled by 1s. Okay, so it's going by 1s vertically. So try and figure out what happened, what's the shift. So describe it as best you can. Up, down, left, right, and did it flip over at all? Okay, describe that and bring your questions into class and we will go over them.